I don't know, maybe 8 years ago. I was watching a movie called Agora. And it's about a female mathematician and philosopher. And I think it's set in the 3rd or 4th century AD. And she was explaining the movement of the sun and the planets. And it was the first time I saw how an ellipse was formed in a really cool manner. We'll see that later. But in that same movie, they had this cone, and she called it an Apollonius cone. And I was so excited. It's like, ooh, I can take this to the class, and I can show you guys, like, physically what a conic section is. So here it is. I asked for it, I looked for it, I found it, I asked for it, and here it is. So cones are really cool things because you can cut them, you can cut them horizontally, vertically, diagonally, and you get all these different sections of which there are equations in math. And obviously, because they come from a cone, they are called conic sections. So if you take, for example, a cone and you slice it completely across, what do you get?
Circle.
A circle. If you cut it semi-diagonally, you get what is known as an oval, or mathematically speaking, an ellipse. It turns out that if you start with an ellipse, like semi-diagonally, and you slowly turn it horizontally, you get a circle, right? So a circle is a special type of ellipse. Later on, we'll see the ellipse. If you cut it completely vertical, you get half of a hyperbola. And if you cut it semi-diagonally, but touching the base of the cone, you get a parabola, okay? So now you know why they're called conic sections. Today we're going to look at the circle, specifically. So, the circle, I'm going to give you something a little bit bigger than, oh no, he does give you the whole thing. This is the equation of a circle. Where h comma k is the center and r is the radius. Now, before you get it like that, you're probably going to get it like this. Notice that these don't have a coefficient, the x squared and the y squared. And notice that they're both positive. Because if you get one of these negative, then it's no longer a circle, it's no longer an ellipse, it's a hyperbola. So as long as both of these are positive, we're good and we know that it's either an ellipse or a circle, okay? Well, how do you know the difference between an ellipse and a circle? These have coefficients if it's an ellipse, okay? So, how are you going to do this? They're going to give you an equation. Let's say they give you, yes, there's a couple of ways of doing this, but they give you this, x squared minus 8x plus 16 plus y squared plus 12y plus 36 equals 25. So what do you do? What do you think you do?
You put this on one side and you want the other?
No, because look at the equation of a circle you have to get to, you have the x's and the y's on the same side.
General form?
That is a general form. This is a general form. So you put numbers on one side and leave x's and y's on the other, and you're going to complete the squares. Okay? So you're going to have x squared minus 8x, that's 1, plus y squared plus 12y, there's the other one, equals 25. Did I write this right? Minus 36. That can't be. I see. Minus 36.
Minus 6.
25 minus 36, right?
Minus
16.
Why minus 6? Oh, minus 16. Yes, minus 16. Okay, so I complete the square here, and I have x squared minus 8x plus 16, right? Because it's this one divided by 2 squared. Plus y squared plus 12y plus 36. Right? And what I do on one side, this is what? Minus.
Negative 27.
Huh?
Negative 27.
Negative 27? You sure?
36 minus 25.
I think it's negative.
11 minus 6. 11 plus 16.
No, yeah, negative 27.
Negative 27. Bye. But I added 16, so I have to add it on this side, and I added 36, so I have to add it on this side.
So it would be equal to 25.
That gives me 25 back, right? And I have x minus 4 squared plus y plus
6.
6 squared. Therefore, my circle has what center?
Negative 4 comma
4 comma minus 6 is my center. And my radius is going to be 5. And
oh, okay.
how do you do that? Well, ideally you use a compass. But at least you've got the center. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. And what is it? It's 4 minus 6. So it's 1, 2, 3, 4. 1, 2, 3, 4, 5, 6 down here. 4 minus 6 here. There's your center, and then you have to do 5 all around. So it's 1, 2, 3, 4, 5. Here's a point. 1, 2, 3, 4, 5. Up here is another point. 5 that way, and 5 down here, and then you connect it with your compass, and you're going to get a circle. Okay. This is one thing they could give you. May I erase? The other type of problem you might get is an even easier one. Find the standard form of the equation. The standard form is the one I told you over here. Find the standard form of the equation of a circle whose radius is 4. They give you the radius. And whose center is minus 3 comma 3. What do you think you do?
You write it
You
out.
put it in the standard equation.
You just substitute in the standard equation. So you know that it's x minus h, which is minus 3, so it's got to be plus 3 squared
Plus.
plus
Y
minus 3 squared equals 16.
Yeah.
Boom, I'm
That's
done.
it?
That's it.
What?
And then it says, write the general form of the equation. This is the standard form.
The other one is general.
How's the general form?
When you multiply everything.
When you extend this, right? So you've got
X squared plus 6x
plus 6x plus 9
plus 5
plus
y squared minus 6
6.
y
y plus 9 equals 16. So you've got x squared plus 6x plus 9, that's 18.
Negative 2 on the other side.
18 negative 2, right?
Yes.
No, positive 2. Plus y squared minus 6y plus 2 equals 0. That's the general form. Isn't that
So
easy?
it has to equal to at the end.
Yes. For the general form, yes. Questions? So this is pretty simple, right? Okay. Do you want to stop it and do a different video?